All right, continuing on in our statistics class, we are moving on to Chapter 1, Section 2, which is about data basics. So we're going to be looking at some basic stuff with our data. Okay, so first off, the data matrix. So data matrix is a way that you just can organize or put all your information in a table so you can see it. You can do this in like a spreadsheet or an Excel spreadsheet or Google Sheets. You can do anything like that. So what it does is it organizes it all so that you can look and go, okay, the first one, this is all the information for it. Second, this is all the information for it. So usually how they're structured is that the vertical up and down is your variables. So you see along here you have your student, the gender, are they introvert or extrovert? There's a whole bunch of other things, and then their dread level on interacting with people. Um, And the dots that you see here, those three dots, basically tell you that there's more going on. There's more information, it's just not shown here. So you see it goes to student 4, then it's dot 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 86, saying that it continues on until you hit 86. The left-right, going from left to right, is each one is an observation. So you see student 1 is a male, an extrovert, their dread was 3, with other information in it. Student 2 was female, she's an extrovert, and the dread was 2. Student 3 was also female, was an introvert, and the dread was 4. So you see going across, all the way across horizontally is one observation, it's one person for it. So all that information going across horizontally is one person. Okay, so now we have that and we have all those different informations and different things that we can categorize people in. So we've got these different variables that we can say male, female, grade level, income, their dread level, uh, education level, yada yada yada, height, shoe size. There's a bunch of different things that you can do. So those are all different variables that we have for them. So all variables are broken up into two separate. You have your numerical and your categorical. Your numerical or each one of these are then broken up into two separate. So your numerical are also broken up into continuous and discrete, while your categorical is broken up into normal, categorical, and ordinal. Now, numerical are usually numbers. How high can this person jump? How fast can they run? How much do they weigh? Those are numbers, okay? That falls into numerical. Categorical are categories, male, female. Grade level would be considered categorical because it is a category that you fall into, okay? What's your race or ethnicity, anything like that. Those fall into categories, okay? So again, numerical is data, and then it can be added, subtracted, taking the average of all those. So broken up into the two separate, we have our continuous, which means that they usually can be taken into a decimal point, and then discrete, which is usually either whole numbers or sets of numbers. So continuous, where you can have decimal points, would be, let's say you're weighing somebody, okay? That would be considered continuous because someone can weigh 200 pounds or 200.1 pounds or 200.04 pounds. So continuous, you have all that. Discrete, they fall in the categories. So you think somebody's hat size, they wear a 7.5 hat. The shoe size, they have a size 8 shoe or 8.5 or 9.5. That's discrete. They're set in numbers. Okay, so that's what it is. You could do age, could also be considered discrete if you're just taking it with, how old are you? I'm 8. How old are you? 18. Okay, you're not going, I'm 18 and a half, I'm 18 and a quarter. That's like that. Categorical, again, data that can be put into groups that are usually not numbers, but they can be, like grade level. So regular categorical or nominal means that there's no ranking in the order of the groups. So if I go the dread level one, what's your dread level? Between 1 and 5. There's no real ranking of it. It doesn't matter for it. And an ordinal, that means that there's groups that are inherently better than others, and they kind of go in order. Better might not be the right word, but they kind of go in a progression. So kind of like your grade levels. Okay, there's the older you are, the higher up your grade is, and that's kind of how it is. So there is some sort of pattern that goes along with it. So that's your type. Okay, so the following group. So if we have these, are they continuous, or are they numerical or categorical? So for the following groups, identify if they would be considered numerical or categorical. Okay, so gender falls into a category. Okay, so gender is a category. You're male or female. Okay, it's not numerical. It's not a number. Okay. Next up is your sleep. So as you see, sleep is your numbers, which means this should be numerical. Okay, and it would be considered continuous because, as you see, they do go into decimals for it. So somebody was more exact. Bedtime. You see, we have 12 to 2, 10 to 12, 12 to 2, yada, yada, yada. That would end up being categorical. And it would be ordinal because you do have some sort of pattern or order that it is can be put into. Next up is countries. So how many countries the person's visited. In this case, for this example, so as you see there, those are numerical and they would be discrete. Okay, so they would be discrete because you can't visit half a country. You either visit the country or don't visit the country, so you won't have like 1.5 or 1.25. Okay, it's either 1 or 2. Last up is dread, and dread is categorical again as well. Okay, so looking for relationships. So looking at relationships between variables, okay, what we want to do is we want to see is there a relationship between the x and the y-axis. Remember, the x-axis is left to right, the y-axis is up and down. So looking at this graph, do you see some sort of relationship between the x and y-axis? As the x increases, does the y increase, or does the x increase, does the y decrease? Anything like that. Okay, so do you see any relationship forming? In this case, I would say that there might be a small relationship. As you see, it kind of looks, it kind of goes down. As the x increases, the y is kind of decreasing, but it's not very strong if there is any. Okay, independent and dependent variables. So independent variables are variables that have no connection between them. Okay, so somebody's height and what hand they write with. Okay, those are independent. There's not a relationship. Taller people aren't more likely to be left-handed or right-handed. It's not. There's no connection. Okay, those would be independent variables. Okay, dependent variables, also known as associated variables, are two variables that appear to have some sort of relationship. Okay, so if there's a negative association, that means that as one variable increases, the other variable decreases. And then a positive association is that if both are increasing, if one's increasing, the other one's increasing. If one's decreasing, the other one's decreasing. So you can think of this as with a positive association. Dependent variables could be like height and weight. People that are taller usually weigh more. Okay, so that would be a positive association right there. Your negative association could be something like people that work out more usually have less health issues. Okay, so that would be it. As you work out more, the health problems drop. Okay, so that would be kind of your negative association. Think of it, this is the negative association is a decreasing graph. Positive association means it's an increasing graph. Okay, it's going up. Thinking of slope. Positive slope, negative slope. So here's some examples of them. So positive linear association is a line, and what we're going to be mostly looking at is we're going to be looking at linear associations. We're not going to be worried too much about nonlinear. We're going to be looking mostly at linear is what we want to look at. So a positive linear association, as you see in this first graph, you see the graph is going upward. As the x increases, the y is increasing as well. In your negative linear association, as the x increases, the y is actually decreasing. So you've got this nice little downward looking. Okay. Nonlinear association basically means that there is some sort of association, but it's not a straight line. So in this case, you see here, it's a curve. It's kind of a parabola shape. It's like an x squared shape. Okay, so as the x increases, your y decreases to a point, and then it increases again. And there's many things that will have this type of association. And then no association at all basically means that there is nothing. There's no pattern formed. Okay, if I take, if I start dropping stuff here and there, it's not going to have any rhyme or reason to it. It's just a random association. Okay. Okay, so one thing that is very important, okay, A pair of variables are either related in some way, meaning they're associated to each other, or they are not, or they are independent. Okay, so that means that if you have two variables, they are either associated with each other or they are independent. You cannot have both. You can't say, oh, this is independent and associated. It doesn't make sense because they're opposites of each other. Okay, so if you have two variables, they are either associated or independent. They cannot be both. Okay, so remember that. Okay, so let's look at this example real quick. So read this paragraph down here, and you want to find three things. Number one, you want to find what are the cases. So what is being examined. Okay. Um, the second part is you want to know what are the variables. Okay. And remember, this is kind of looking at a case study again. And then number three is what's the research question. So what you might want to do is you might want to work backwards. What's the research question, okay, for this? And then find, okay, what are the variables? And then what types they are. So are they numerical or categorical? And then the cases. So again, what's being studied? What's going to be in your controlled and your treatment group? Okay, so I'll give you guys a few seconds to figure this out. Okay, so looking at this, first thing we are saying is what are the cases, so what's being studied. And the cases are going to be all the births that took place from 89 to 93. Okay, so the eligible studies for this, the 143,196 births that took place in those 4 years, those are what you would be looking at. Okay, so those would be your cases. Those are what we're trying to study. Next is your variable. Your variable ends up being the measurement of the air quality. So all of them, the carbon monoxide, the nitrogen dioxide, the ozone parts per million, all those are going to be calculated, and all those would be continuous and numerical. Okay, so they are continuous because you can have decimals for them, and they are numerical because you're going to get actual numbers for them if you're trying to find parts per million. Okay, so that's your variable in this case. So that's what's going to be affecting it. The higher those measurements are, does the gestation period fall? And that's our question. Our question is there an association between the air pollution exposure and the preterm births? Okay, so basically we're trying to see, is there, if the higher the particles are in the air, the shorter the gestation period is. And so that's what we're going to be looking at, and that would be the question in this one. Okay, so this is what a lot of them is going to be, is you're going to have to be reading through like a paragraph, and you have to pick out parts of them. Okay, so that's an example for kind of what you're going to have. So homework for this one is, again, off the digital copy of the book, numbers 1 through 6. So 1 4 through 1 6. Okay, so you're skipping 1 3 because we actually just did 1 3.